Hello and welcome. My name is Mr. Asprey and this is Edexcel IGCSE 2022 Paper 2H. Hopefully you will enjoy this and you will find it useful. If you do, please do like the video, and if you're not already, please subscribe. Got lots of GCSE content coming out in readiness for your exams this year. So please like, subscribe and share. That'd be great. Okay. This paper is a good paper, and the couple of the questions at the end are really tricky, so make sure you watch those ones as well, and let's get into it. Question number 1, and we are told lots of information about A, B, C and D. First off, I'm going to use the fact that the mode, which is the most frequent number, is 9, and that must be D, because D occurs more than any other. So D is 9. It tells me the median next is 8, so the median is the middle number, and if there's an even amount, like there are here, then we take the 2 in the middle, and we take the average of that. So if 9 is D, then 8 is in the middle, and therefore C must be 7. So we have here C is equal to 7. And then the range is the biggest minus the smallest, and we're told that is 4. So we know that A must equal, 9, and the gap between them is 4, so this must be 5. And then finally, how do we work out B? Well, the only bit of information we haven't used is the fact that these numbers are in order and they're not equal to each other. Each one is bigger than the last one. So that means that B must be distinct, it must have its own number, and it must go in between 5 and 7, so it must be 6. Okay, first off, let's draw this line. Y equals 1 is a horizontal line where every coordinate has the y value of 1. X equals 2 is a vertical line where every x coordinate on that line has a value of 2. It does say label as well, so I'm going to make sure that I clearly label which one is which. And next one, we've got x plus y is equal to 7. Well, what we can do is a quick cover method here, is what I call it. When x is 0, I can cover up that, and that tells me that y equals 7. So I go to x0 and y7 and draw a cross there. Okay, what about when y equals 0? Well, y would disappear and x would equal 7. So I go along where the y equals 0 and the x must be 7. And then I can draw a line connecting those 2 points, and I've got my line drawn. And then it asks me by shade the region where it satisfies all 3 of these. So we want the y coordinate to be greater than 1, so it has to be above the line here that we drew. We want the x coordinate to be greater than 2, so it has to be to the right of this line that we drew. And we want the x plus y to be less than or equal to 7, so it's got to be below this line that we drew. And you can see that it converges upon this triangle in the middle, which is going to be our region, which we can shade in. I mean, 99% of the time it's always the triangle in the middle. So if in doubt, just shade the triangle in the middle. Okay, we've got speed, distance, time. So I draw my triangle like this, and I would write speed, distance, time. And I'm looking for the speed, so I cover up the speed part of the triangle, and that tells me I have to do the distance divided by the time. So speed is distance divided by time. The distance is 3980, and the time needs to be in hours, because the distance is good, it's in kilometers, and our speed needs to be in kilometers. but the time needs to be per hour, and at the moment it's hours and minutes, so we need to change that. Now you can use your calculator here. You can press 5 and this button here, this one underneath where it says fact, you can press that, and then you can press 24 oops, you press 5 and then that button, then 24, then press the button again. You can press equals, and it tells you that's 5 hours, 24 minutes and 0 seconds, and then you can press the S to D button, and that gives you a decimal. So 5.4 is the number of total hours. So I can do 3980 divided by 5.4, and we have 737. To the nearest whole number is 737. Subtraction of fractions. So first off, we need to convert them into an improper. We've got 5 wholes here, and we've got thirds here. So how many thirds can we fit into a whole? We can fit 3. So how many can we fit into 5 wholes? We can fit 15. Plus we have a 1/3 left over as well. So that's a total of 16 thirds. And let's look at this. We've got 2 wholes and we're trying to put them into sevenths. Well, how many sevenths can you fit into one whole? 7. So into 2 wholes, 14. And we've got 6 over there as well. So that is a total of 20 sevenths. There's a subtraction sign between them. And we now need to make a common denominator. So the lowest common multiple of 3 and 7 is 21. So I'm going to times this one top and bottom by 3 and this one top and bottom by 7. I can use my calculator here to do 16 times 7, which is 112 over 21. And 20 times 3 is 60 over 21. So we have a total of 112 minus 60, which is 52 over 21. And how many 52s fit into 20? Oh, sorry, how many 21s fit into 52? That is 2 wholes, and 21 doubled is 42, which leaves 10 left over to make 52. Okay, we've got a funny looking shape here, and we are told the height of the shape, and pretty much everything is on the diagram already, but we are told the area of the total shape, A all the way around to H. So the first thing I'm going to do is split it, and I'm going to work out the area of the rectangle below, which is 28 by 12. So I'll do 28 times by 12, which is 336. So that tells me what this area at the top X is, because I know the total area is 434, and the total area is X plus the bottom area. So that bottom area there will be 434 minus 336. And that will give me the top area, the trapezium. Okay, great. Now the area of a trapezium is given in your formula booklet, and it is 1/2 A plus B multiplied by H, where A and B are the 2 parallel sides. So let's first off work out what the base is. Well, the base down the bottom is, the whole thing across is 28, and we've got a 5 there and a 5 there. So that leaves 18 left over to go across the bottom. And the height of that shape, well, I know the height of the rectangle at the bottom is 12, and the overall height is 20, which means this height here must be 20 minus 12, which is 8. Okay, so now we can apply the formula. We know the area of that trapezium is 98, we've worked that out already. That's equal to 1/2 of the 2 parallel sides, so the 2 horizontal sides, which are 18 plus the one at the top, which is CD, which is what we're actually trying to find, multiplied by the height or the gap between them, which is 8. Okay. So we have a half times 8 is 4. So we can write that as 4/18 plus CD. And multiplying out 4 times by 18 is 72. Plus 4 lots of CD. Subtract 72 from 98 is going to give us 26. And then finally divide through by 4, we get 26 over 4. Or if you prefer, 6.5. There's a classic trig SOHCAHTOA question. So first let's label the sides. That is the opposite because the angle is facing opposite it. The right angle always points towards the hypotenuse, and the adjacent is next to the angle. So which sides do we know? Which sides do we have? Or what sides do we want to find out? Well, that is the adjacent and the hypotenuse, which means we're going to have to use cosine. So I like to write it out as cosine of the angle A over H. And what am I looking for? I'm looking for A. So I'm going to cover A, which tells me that I need to multiply these two down the bottom. So I write that A is equal to cosine of the angle multiplied by the hypotenuse, 9.5. So I type in cosine. I just need to double check something. I need to make sure that we are in the correct mode, because I can see there's an R at the top, which is no good for GCSE. We need to change that to degree, and we go 42 multiplied by 9.5, and to one decimal place that is 7.1. Change speed of 81 kilometers per hour to speed in meters per second. Well, 81 kilometers, the word per essentially means out of, which means divide by 1 hour. So 81 kilometers per every 1 hour. And then what I can do is I could just convert the top into meters and the bottom into seconds. So converting the top, 81 kilometers is the same as 81,000 meters, and 1 hour is the same as 60 minutes, and in every minute there are 60 seconds. So it's 60 times 60 seconds. So this is going to give me 81,000 over 60 times 60, which is 22.5 meters per second. Okay, Benaz makes 300 celebration cards. Okie dokie. And these are the ratio in between them. So let's work out how much of each she makes. So the total amount of ratio is 7 plus 5 plus 3, which is 15. And we need to split 300 cards up into 15 pieces. And each piece, therefore, is worth 20 cards, which means birthday has 7 pieces, so 7 times 20 is 140, and anniversary has 5 times 20, which is 100, and congratulations has 3 times 20, which is 60. Okay, 2/5 of birthday cards have numbers on it. First off, I probably should read the question. We need to find the ones that have numbers on them. And 2/5 of the birthday cards have numbers on it. So this one, I need to do 2/5 of 140. So I can just use my calculator to do that. 2/5 of means times 140, which is 56. Okay, that they have numbers on it, great. And we have 36% of the anniversaries. So we have to do 36% of 100, which I'm not going to use my calculator to do that because 36% of 100 is just 36. And then we have none of the congratulations cards, so that's 0 there. So the total that have numbers on are 56 plus 36, which is 92, all over the total amount, which is 300. So it's 92 over 300, and it asks it in its simplest form. We can have our calculator help us out with that. 92 over 300, press equals, and we get 23 over 75. Wonderful. Okay, Pasha invests $50,000, lucky him, in a savings account for 4 years. Okay, so with compound interest, so it's 1.3%. So what we do to find the multiplier is we start with 100%, and because this is interest, it's savings, we're going to be increasing. So we're adding on 1.3%, and then we divide it by 100 to get it into a decimal. So putting that into our calculator, I do 100, a fraction button first, 100 plus 1.3, all over 100, and that gives me 1.013. So that is the multiplier. Then I take my amount which I'm investing and I multiply it by the multiplier. But I want to do this 4 times. I want to do it every single year for 4 years. But rather than writing it out 4 times, instead what I can do is I can just multiply it by the multiplier to the power of 4. So I press 50,000 in my calculator multiplied by 1.013 to the power of 4, which gives me 52,651 to the nearest dollar. Simultaneous equation, I can see the quickest way of doing this is lining up the y's, because it means I only need to multiply the bottom one. So I keep the top one the same, and I multiply the bottom one by 3. And then because the 3 y's are the same now in terms of the value, the number, but the signs are different, it means I need to add the 2 together. Because if the opposite signs you add, if they're the same sign you subtract. So 7 plus 9 gives me 16x. The y's will cancel out and that gives me 24, which means x is equal to 24 over 16, which is 1.5. And then we substitute back in. So I am going to pick the top one because it's all positives. It makes it easier, I think. We do 7 times 1.5 plus 3y is equal to 3. 7 times 1.5 is 10.5. So we have 10.5 plus 3y is equal to 3. Subtract 10.5 from both sides. 3 minus 10.5 is minus 7.5, and then we divide through by 3 and we get minus 2.5. So 1.5 and minus 2.5. Factorise, I'm looking for two numbers that times together to make minus 24 and add together to make positive 5. So those two numbers are minus 3 and positive 8. And we factorised. Next we need to solve. So we write that x minus 3, x plus 8 is equal to 0. So one of these brackets must be 0 because it's the only way that I can get a 0 by multiplying two things together is if one of them is 0. So either x minus 3 equals 0 or x plus 8 equals 0. And if that's the case, x equals 3, or in this case, x equals minus 8. Okay, Larry is a delivery man. He has 7 parcels to deliver. The mean weight of the 7 parcels is 2.7 kilograms. Well, to work out the mean, you take the total weight, divide it by the number of parcels, in this case 7, and that will give you the mean. So I can actually work out what the total of these 7 are straight away by doing 2.7 times 7. So 2.7 times 7 is 18.9. So that's the total of all of those packages. Larry delivers 3 of the packages. Each of these 3 has a weight of W. So the total weight of these is 3 times W. The mean weight of the other 4 parcels is 3.3. So those other 4, again, their total divided by 4 this time equaled 3.3. So the total of those 4 is 3.3 times 4, which is 13.2. So what have we got overall? We've got the 7 is 18.9, and that's made up of these 3 and these 4. So we can solve this equation to get that 3w is equal to 18.9 minus 13.2. So 18.9 minus 13.2, which is 5.7. So 3w is 5.7. Dividing through by 3 gives me 1.9. Yes, it does. Okay, we have a cumulative frequency table. So in order to work out the cumulative frequency, we add up as we go along. So we start with 7, we add on the next value of 25, and 7 plus 25 is 32. We then add on 20, so that will give me 52. We then add on 14, which will give me 66. We add on 8, which will give me 74. And we add on 6, which will give me 80. And we go up to check, yes, there are 80 people, so we should end up with a total cumulative frequency of 80. And now it's asking us to draw that graph. The key point is that you must plot along the x-axis these numbers here, the endpoints of the intervals. So 20 goes with 7. 30 went with 32. 40 went with 52. That's all I can remember. 50, 66. So 66. And then it was 74. And then it was 80. And once we've done that, the lowest possible number we can attain is 0. So it will go through 0, 0. And I'm going to draw that graph. A nice smooth curve as best you can, connecting up the points. Like that. And then we are asked to work out the median of the 80 people. Well, that would be the middle person, and if there are 80 people, we're looking for the 40th person. So we go to across at 40 like that, and then we go down like this, and we get an answer of 34. And that might be slightly different on your graph, but there is always some leeway. Okay, we're now asked that of the 60 people, 60% of those people who are aged between 18 and 65 are going to work. None of the other people are going to work. Okay, so we need to find 60% of the people which are between 18 and 65. So at 18, we go up, we go across, and we have roughly about 5 people who are less than 18. And at 65, we go up along here, all the way right up to the top, and across, which tells me there are 78 people less than 65, but maybe more usefully, there are 2 people who are older than 75. So how many people are in between 18 and 65? Well, there are 5 people who are too young, and there are 2 people who are too old. So I would say there are about 73 people who are between 18 and 65. So we take 60% of 73. So we do 60% of 73, and we get 43.8. So roughly 43.8. So the number of people I'm going to guess at 44. Remember, it does say estimate, and it says the number of people, so it does have to be a whole number. Multiplying a triple bracket, what I recommend doing is just ignoring the first bracket and just focusing on the second and the third to get started with. So that's going to give me 2x plus 3 multiplied by x plus 4. This is going to give me 2x squared plus 4x plus 3x plus 12. Simplifying is going to give me 2x squared plus 11x plus 12. I then reintroduce this first bracket. Write it on each line like this. And then we are going to multiply out these 2 brackets. And the way that I do it is I take the 5 and I multiply it by everything in the other bracket on the top like that. And then I take the minus x and I multiply everything. I multiply it by everything in the second bracket down the bottom like that. So let's do the purple lines first. That's going to give me 10x squared, 55x plus 60. And then the greens is going to give me minus 2x cubed. It's going to give me minus 11x squared. And it's going to give me minus 12x. And then we need to collect up the x cubes first, of which there is just minus 2x cubes. The squares, we're going to have 10 minus 11, which is going to be minus 1. And the x's, we're going to have 55 minus 12, which is positive 43. And then finally, the constant term is just plus 60. Okay, we're rearranging to make C the subject and C appears twice. So that means we're going to have to collect all the C's on one side and then factorise, then divide. First off, this is nice because we've got this minus 7 here. Let's move that to the other side by adding it. And now we've just got a single fraction on the right, and that means I can multiply both sides of this equation by 4 plus C to get rid of that denominator. So I get G plus 7, I'll put that in brackets and I'll multiply that by 4 plus C, and by doing so that will cancel the denominator on the right completely. Multiplying out these brackets is going to give me 4G, it's going to give me plus GC, plus 28, and plus 7C is equal to C plus 3. And then what I'm going to do is I'm going to move all of the terms which have a C in it to the left side, and all of the terms that don't have a C in it to the right side, like that. So what will I have on the left side? Well, I've still got that GC there. I have a 7C, but I'm moving this 1C over, so that's going to subtract, so that's going to give me 6C. And on the right side, I've got 3, but I'm subtracting 28 over, so that's going to give me minus 25. And I've also got this 4G, which I'm bringing over, which is going to be minus 4G. I can now take out a factor of C, which I need to do because that reduces the times that C occurs from 2 times down to just 1, which is perfect. And now I can divide through by this factor of G plus 6, and I get C is equal to minus 25 minus 4G over G plus 6. Algebraic fraction, I'm going to want to make a common denominator, in this case of 6. So I need to multiply this one top and bottom by 2, which is going to give me 8x plus 10 over 6. I'm going to multiply this one top and bottom by 3, which is going to give me 9 minus 6x over 6, and that's equal to 13. And I can now combine my fractions, but I have to be very careful when I combine my fractions. Very careful. And that's because this is the most common mistake I see in GCSE maths, is forgetting that a minus and a minus is going to make a plus. Right, let's see what's going to happen. So I'm going to write 8x plus 10 minus, and I'm going to put this in brackets, 9 minus 6x all over 6. So I've just combined those two fractions there. I'm going to expand these brackets. I'm going to get 8x plus 10. I'm going to get minus 9. And I'm going to get a minus and a minus makes plus 6x. And that is where so many students forget to do the double negative. Okay, I can now simplify that top line to get 14x plus 1 over 6 equals 13. Timesing both sides by 6 is going to remove the denominator on the left, and 13 times 6 is 78. Subtract the 1 from both sides to get 77, and divide 77 by 14, which is the same as 11 over 2. Quadratic inequality. So first off, we've got to factorise this, and to do that I will use the AC and B method. So the A value is 2 and the C value is minus 30. So timesing those together gives me minus 60, and the B value is minus 7, which means I have to find two numbers which times together to make minus 60 and add to make minus 7. And those two numbers are minus 12 and plus 5. Yes, that works. Okay, so my way of factorising quadratics, which are a bit tricky, is I take the a value, which is a 2, and I write 2, in this case y, 2 all over 2. And that's all because the a value is 2. I write 2 in these positions. We then take our minus 12 and our plus 5, we put them in the brackets, and we ask ourselves, how can we simplify this? Well, I can divide the left bracket there by 2, and that will simplify that down to y minus 6. And that gives me my factorised form. So we want this to be less than or equal to 0, but I want to find out what these critical values are. So this bracket here, when does that equal 0? Well, it equals 0 when y is 6. And this one here, well, 2y plus 5 equals 0 when 2y equals minus 5, so y equals minus 2.5. So if I were to draw this quadratic, I know that it would go through minus 2.5 and it would go through 6. So it would look like this. And we want to know where this quadratic is less than 0. Well, it's less than 0 when it's below the axis like that. And that is in between minus 2.5 and 6. And we write it like this. We write that y is greater than minus 2.5, but it's less than 6. And we also write it equal to because the symbol in the equation is a less than or equal to symbol. Okay, we have 100 farmers and goats, sheep and chickens and lots of information. I'm not going to read it all out. Put it in the Venn diagram essentially. Best place to start is in the center. And that's where all three overlap, and we can see here that there will be 6 people who have goats and sheep and chickens. And then let's go for the doubles. So 11 have sheep and goat, but we have to take away the 6 that have already been included because those 6 people in the center have sheep and goats as well, which leaves 5 left over to go in the sheep and goats section. Next one, 17 sheep and chicken, but take away the 6, so that leaves 11 for sheep and chicken subset there. And 18 have goats and chicken, take away the 6 in the center, leaves you with 12 to go in this little region here. Okay, let's look now at all of the sheep, of which there are 31. But how many are already in the sheep section? 5, 6 and 11 makes 22, which means there's 9 left over to go in the just sheep section. And here, 53 chickens. How many are already in the chickens section? 12, 11 makes 23, plus 6 is 29. So we need to do, was it 53? Yes, 53 minus 29, which is 24, goes here. And we are not told about the goats, but we're going to have to work that out ourselves once we know that 20 don't have any at all, so 20 goes on the outside. There's 100 in total, so the only subset which is not filled is the just single goats. So we have to do 100 minus 20, 24, 11, 6, 12, 5 and 9. So what's left over is 13 to go in the just goats section. Okay, find the number of goats, or the number of people in the goats region, the number of farmers who have goats. Well, it's everyone in this set here, so that's 13 plus 5 is 18, plus 12 is 30, plus 6 is 36. We want goats and sheep not. Okay, so let's first, goats union sheep are all of the farmers who have goats or sheep or both. So that is G union S. And we want not that. So therefore we need everyone outside of the yellow rings. So that's 20 plus 24, which is 44. And then now we have not goats and chickens. So we want the not goats, and they have to also have chickens as well. So you have to have chickens and you're not allowed to have goats. So therefore you must be in this region here. Those are all the people that have chickens and they definitely don't have goats. And that is a total of 35. One of the farmers who has chickens is chosen at random. Find the probability that the farmer also has goats. Well, if the person had chickens, then they must have been in the chicken circle, which is this one here, and that is a total of 53. And they also have goats, so they must be these people here, so that is 18 out of 53. Okay, m varies directly as the cube of h. So we can write that m is proportional to the cube of h. And whenever we do a proportionality, we can change it into an equation by writing that it is equal to some constant k multiplied, in this case, by h cubed. We then substitute in our two bits of information that were given. So we get 4 is equal to k multiplied by 0.5 cubed. And that can tell us what k is equal to by dividing both sides by 0.5 cubed. So we go to our calculator and we do 4 divided by 0.5 cubed, and we get 32. Which means that the formula is that m is equal to 32 multiplied by h cubed. And we need to find h when m is 500, so we sub in 500 for m. That's equal to 32 times h cubed. So to find h cubed, we divide 500 by 32. Which gives me 125 over 8, which is nice and neat because I know those two are cube numbers. So that's going to be great when I need to cube root. And when I do cube root 125 over 8, I get 5 over 2. Perfect. Okay, we have a... we have x, we want to work out the upper bound of x. Okay, so I'm going to have 2 multiplied by a. Now if I want x to be the upper bound, I want a to also be the upper bound. But then I'm going to take away b, and if I want x to be as big as possible, I need b to be as small as possible. I want to take away as little as possible. And then I'm going to divide by f, and I want f to be as small as possible, because when I divide by a smaller number, I get a bigger overall total. And this is going to give me my upper bound for x. Okay, so now let's work out each of these individual letters. So I'm going to start with a, and I know that's 7.5, and I know it's to 1 decimal place. So if I was only using 1 decimal place and I had to go up, it would be 7.6, and if I had to go down, it would be 7.4. Now the upper and lower bounds exist halfway in between these values here. I want the upper, so it's 7.55. Let's look at b. So b is 3.42, and I'm using 2 decimal places only. So the next number along would be 43, and the one before would be 4, 1. Now for b, I want the lower, so I'm going to look at this side here, and halfway between that is 3.415. And then I'm going to look at 2 to the nearest whole number. So if I'm only using one whole number, the next number up would be 3, and the one before it would be 1. So the lower bound would be here, and the upper bound would be here. But I want the lower, which is halfway between, which is 1.5. So now I just substitute in. So I'm doing 2 times the upper of a, which was this one, 7.55, minus lower of b, which was this one, 3.415. all over the lower of f, which is 1.5. So I go here, I do 2 times 5.77 minus 3.41. Probably should have put it as a fraction, but it's fine. I just press equals, and then I divide by 1.5. And that gives me a perfect number. I don't need to round, 7.79. Okay, question 9 looks like a standard algebra question whereby you need to express a in the form of just y's and integers p, q, r, and s. So it looks scary, but essentially what we need to do is eliminate x by substituting it in over here. So I write a is equal to 14 over 3, and rather than writing x, I don't want x anymore, so I'm going to replace the x with 7 over 4y minus 3. So 7 over 4y minus 3. And then I'm going to subtract 7. Okay, I've got a denominator, so I've got a fraction in my denominator which I don't like. So what I'm going to do is I'm going to look at that fraction and I'm going to multiply the top by 4y minus 3, and I'm going to multiply the bottom by 4y minus 3. And I can do that because timesing the top and bottom by the same thing is the same as timesing by 1, which does not change the value of the fraction. Okay, so the top becomes 14 4y minus 3. Now what's going to happen to the bottom? Now when I multiply the denominator by this 4y minus 3, I have to do it to each term along the denominator. So firstly, doing it to the this first term here, well, the whole reason why I've multiplied by 4y minus 3 is to cancel that denominator. So that is just going to give me 3 times 7, which is 21. But this term here, minus 7, that also needs to be multiplied by 4y minus 3. So now we have a fraction without any fractions in it, which is much nicer in it. 14 times 4 is 56. 14 times minus 3 is 42. All over 21 minus 28y, and don't forget the double negative there, plus 21. So in total, and how do they want us to write it? They want us to write it with the y's first. So 56y minus 42 and minus 28y and 42. But very sneakily, we can simplify this because we may have spotted here that we have factors of 7 in each of these terms. So we're going to divide the top by 7 and the bottom by 7. And what is that going to give us? It's going to give us 8y minus 6 over minus 4y plus 6. And we're still not done because in fact this has a factor of 2 on the top and a factor of 2 on the bottom. So this is going to give us 4y minus 3 over minus 2y plus 6. Plus 3. And now we are done. because it was very important that we had this here. It needs to be in its simplest form. Question 20. We can see from the diagram that we've got a shaded region, we've got these circles that just touch the square, and we're told that the shaded region has an area of 40. So let's put some notation here. Let's call this R, that's the radius. And if we come down here, this will also be R, this will be R, and this will also be R. And it'll be the same going across as well. That will be R, that will be R, and we'll have an R here and an R here. So what is the area of the square? Well, the area of the square will be, well, 4R is the height and 4R is the width, so it'll be 4R times 4R. And what is the area of each of these circles? Well, that's just pi r squared. So what's the area of the shaded? Well, first off, we know it's 40, but it's also the square, which is 4r times 4r, which is 16r squared, minus 4 of the circles, so 4 pi r squareds. So this gives me that 40 is equal to, now this right hand side can be factorised. I can factorise out an r squared, and that gives me 16 minus 4 pi. So therefore I can divide through by 16 minus 4 pi to get 40 over 16 minus 4 pi is equal to r squared. And then to work out r, I would square root 40 over 16 minus 4 pi. Great, so let's do that. The square root of fraction 40 over 16 minus 4 pi. 3.41. I'll keep that in my calculator because I want to use the exact value, but I'll write it down there so the examiner knows the steps I'm taking. Work out the perimeter of the square. Well, the perimeter will be 4r, 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 and 4r. So the perimeter is equal to 4 times 4r, which is 16 times r, which is 16 times 3.41 ... But we've got that in our calculator, so we can just times this by 16, and we get an answer of 54.6 to 3 significant figures is 54.6. Question 21, vectors question. We're seeing these questions come up lots and lots recently, and they are challenging. So we have a triangle, we have that straight line, all shown nice and clearly, but what's not shown for some reason is that a to p is 2a plus 8b. And it says work out the ratio between a and q and b. So what we really need is we need an expression for a to q, and we need to find two expressions in order to solve simultaneously. So the first thing I'm going to do is I'm going to work out an expression for a to b, and this is minus 4a plus 6b. And then I can write that a to q is some fraction, I'm going to call it x, of minus 4a plus 6b. It could be a half, it doesn't look like a half, but it could be a third or a quarter, I don't know, but it is some fraction, and let's just call it x for now. And then I need to do the same thing, but I need to almost come about it from a different perspective. I need to get another expression for a to q, but I need to write it in a sort of different way. So now I'm going to look at o to p, because I haven't looked at that yet. And o to p is 4a plus 2a plus 8b. So that's equal to 6a plus 8b. Okay. Now let's notice that O to Q is on that line, so it's some fraction of that line. So I can call it, let's say, y lots of 6a plus 8b. And now I have that, I can get another expression for a to q in terms of y, which is exactly what I want. I want two expressions for a to q, one in terms of x, one in terms of y, and then I can solve simultaneously. So a to q is going back this way and then using my O to Q like that. So it's going to be minus 4a plus y lots of 6a plus 8b. Okay, great. Now we've got two expressions for a to q and they must equal each other. So I can write that x lots of minus 4a plus 6b is equal to minus 4a plus y lots of 6a plus 8b. But not only do they equal each other, their components, a and b's, must also equal each other as well. So I'm going to expand out and I'm going to then write them in terms of a and b. So the first term I'm going to get out by expanding these brackets is minus 4x a and plus 6x b, and that's equal to, how many a's are we going to have? Well, we're going to have minus 4, and then when I expand out I'm going to get 6y lots of a, so plus 6y, and that's how many a's I have. And then what about b's? Well, I've just got this y times 8b, so I could write that as 8yb. Okay, so let's first look at the b's. These must be the same. So we can say that 6x is equal to 8y. And then afterwards, let's look at the a's. And these must be the same. So I can say that minus 4x must equal minus 4 plus 6y. Okay, right, now let's try and solve these simultaneously. So what I might do is multiply this one here on both sides by 3, and that's going to give me 18x is equal to 24y, and then I'm going to times this one on both sides by 4, which is going to give me minus 16x is equal to minus 16 plus 24y, and I've done that because now I've lined up the y's. So I can replace the y on this one, 24y, with 18x. So I can write minus 16x is equal to minus 16 plus 18x. And then rearranging, that's going to give me, if I plus the 16 to that side and plus the 16x to that side, it's going to give me 34x. So therefore I get that x is equal to 16 over 34. So x is equal to 8 over 17. Great. So now let's just remind ourselves what x actually is. Well, x was the ratio of, or was the fraction of the line AB that AQ is. So this is 8/17 of that line, which means the other part must be 9/17, which means the ratio must be 8 to 9. Question 22 is probably the hardest question on the paper, It says that we have a kite and we have the diagonals AC and BD, and it's drawn on a centimetre square grid. We've got the point A. We're told that the diagonals of the kite intersect at M with that coordinate, and we're told a couple of the lengths, and it says work out the coordinates of B and D. So if it's tricky, draw picky. And what I'm going to draw is just a random kite that looks like this. And it says here A, B, C, D, which means I can write A, B, C, and D around in that order. And diagonals, well, a diagonal is a vertex connecting to another vertex which aren't directly connected. So in this case, A and C, and D and B, just like that. And we know that kites their diagonals meet at right angles. That's a property of a kite. And I'm told that the coordinate of A is -3, 4. Now I know that's not to scale, but that doesn't quite matter really. We're just going to use this diagram to get an idea of how to solve the question. And we've got M as well, which is here, and this is 0, 2. Okay, we're trying to find the 2 points B and D. And what we know about B and D is that they are actually on this diagonal line BD. So let's try and work out what the equation of the line BD is. So I know that the gradient of A to M is equal to the change in the y, which is 4 minus 2, over the change in the x, which is -3 minus 0. So that's 2 over -3. So therefore the gradient of D to B will be perpendicular to that gradient. So it's the negative reciprocal, which means we flip the fraction over and we multiply it by a negative. So this is going to turn into 3 over 2. That's the perpendicular gradient. Okay, great. We also know that M is on this line, so I can get an equation of the line is y equals 3 over 2x, and then in fact M is quite conveniently 0, 2, which is the y-intercept, which means we just need to plus on 2. So that's the equation of BD. Okay, we also need to use the fact that this is 6.5 and this is 6.5. So we're going to have to use the equation, the length of a line formula. Now this point here, B, is an xy coordinate. And what I know about the point B is that it's on this line, y is equal to 3 over 2x. So that means that I could write B as whatever the x coordinate is, the y coordinate is equal to 3 over 2 times the x coordinate plus 2. I know that because B is on the line where the y coordinates equal 3 over 2 times x coordinates plus 2. And now we're going to use the this line here. So how do I work out the distance between 2 points? So we have to use the length of the line formula, and that is that we take the x coordinates and work out the difference between them, and we square it, and then we add on the difference between the y coordinates and we square that, and then we square root the whole thing, making use of Pythagoras' theorem. Okay, so let's have a look at the difference in the x coordinates. Well, we have x at the point B, and then we're going to have minus 3. And the y, so the y at the point B, we've just shown is 3 over 2x plus 2. And then we're going to take away the y value at the point A, which is 4. And then we're going to square that. And then we're going to square the whole thing, and that is going to equal the length of the line, which is 6.5. Okay, so now if I square both sides, I'm going to get 6.5 squared on the left-hand side, which is 169 over 4. And now I'm free to expand these brackets, which I'll just write out a bit neater. Like that. So I will get x squared plus a 3x and another 3x, which will give me 6x, plus 3 times 3 is 9. I will get 3 over 2x times by itself, which is be 9 over 4x squared. I'll then get a 3 over 2x times minus 2, which will be minus 3x, and I'll get another one of those, so it'll be minus 6x, and then I'll get a minus 2 times by itself, which will give me a plus 4. Okay, next step, I can cancel these, which is nice and neat. I can times everything by 4 as well, so that'll get rid of the 4 there. This will give me 4x squared plus 36 plus 9x squared plus 16. So I get 169 is equal to 13x squared plus 52. And all of these are divisible by 13. So that gives me 13 times 13 is 169. That gives me x squared, and that gives me 4. So great, this tells me that x squared is equal to 9. So x is equal to plus or minus 3. Okay, going back up to the top, we are told that the b one has the positive. So therefore, this b coordinate in here, the x value is 3. And what's the y value? Well, we can use the fact that it's on that line again to work out the y value. So the b will be 3, and then it will be 3 over 2 times 3, which is 9 over 2, plus 2, which is going to give me 6.5. Okay, so that's the b value. So now we can work out what d is equal to. And we can do that just by the sort of symmetry of the kite. So because m is the midpoint, over here I have 3 on the x, and then I go to 0. So over here it's going to give me minus 3. We actually knew that already because the other solution to the quadratic we solved was minus 3. And the y value, again, it will be on that line again. So I can just sub it into y is equal to 3 over 2x plus 2, which is going to give me 3 over 2 times negative 3 plus 2. It's going to give me negative 2.5. And that is our final answer for B and D. Here's a classic graph transformation question. First off, we should know what our cos graph looks like without any transformation. So just y is equal to cos x. And that will go up to 360. The halfway point here will be 80. This point will be 90. And it will go between 1 and minus 1. Okay, now what will happen when we do a graph transformation which is f of x over 2? Well, that's going to be a stretch in the x-axis when it's inside the bracket like that, but it acts in reverse, so rather than it halving the x-coordinates, it's actually going to double them. It's going to stretch them out further. So in fact, the graph is going to stretch out much further like this, and then up there, and then off that way. So where it cuts here, A is actually going to be here at 180. So it's 180 and then 0. And where it goes down to that minimum point there, it used to be 180 minus 1, but now it's 360 minus 1. And the final question, indice rules here. I can spot already that we've got powers of 3 acting here. So let's, well, first off actually, let's divide through, because the whole top line is times by 18, the whole bottom line is times by 6, so we can take a common factor of 6 out. So this becomes 3 and this becomes 1. Okay, and now what I'm going to do is I'm going to change all of my numbers into powers of 3. So I've got 3 to the 1 multiplied by 27 is 3 squared, but when I square root, 3 cubed, but when I square root, that raises it to the power of a half. When you square root something, it's raising it to the power of a half. And then that has been raised to the power of 4n plus 6. And that's all over 9 is 3 squared, and that's been raised to the power of 2n plus 8. And this is equal to 3 to the x. Now, what do we do when we have these brackets and we have powers outside of the bracket like that? Well, we multiply those indices along. So what would I get if I times 3 by half by 4n plus 6? Well, let's half 4n plus 6 first. That will give me 2n plus 3. And then let's times that by 3. That will give me 6n plus 9. So I have 3 to the 1 multiplied by 3 to the 6n plus 9. And that's all over. And again, I'm going to multiply these two powers here because they're either side of the bracket like that. And that's going to give me 3 to the 4n plus 16. Okay, now what do we do when we're multiplying two 3's in this case? What happens to the powers? We add them. So this is going to give me 3 to the power 6n plus 10 all over 3 to the 4n plus 16. And what do we do when we are dividing 3's? Well, we subtract the powers. So this is going to give me 3 to the, subtracting these is going to give me a 2n, and a 10 minus a 16 is a minus 6, is equal to 3 to the x. And now because we have both sides are 3 to the power of something, these two somethings must be the same. So we can say that x is equal to 2n minus 6. And we are done. I hope you enjoyed that. I hope you found that useful. Please do like it if you did, and please do subscribe for more content. I've got a series coming out soon for GCSE where I'm going to go through every single topic with exam questions, so stay tuned for that. And in the meantime, if you could share this video with people that you know are doing IGCSE, that would be great. And bye for now.